Okay, good morning, everybody. Welcome to the second webinar of the day. This one is all about the decommissioning of Building 250 at Chalk River Laboratories. Before we get started, CRL is located on the unceded and unsurrendered territory of the Algonquin and Anishinaabe people. As an organization, CNL recognizes and appreciates their connection to this place. CNL also recognizes the contributions that First Nations, Métis, Inuit, and other Indigenous peoples have made, both in shaping and strengthening this community in particular, and this province and country as a whole. So a few housekeeping details before we get started. So there is simultaneous translation for this webinar. If you would like to hear it in French, please click the globe icon on the bottom right. And you can select the language. There is a slight lag because it's live translation. Today's webinar is scheduled for 1 hour. We anticipate 30 minutes-ish presentation with the rest open for Q&A. To submit a question, you can submit it anytime in the Q&A type function. And we will take all the questions up at the end. And if we run out of time, we can send written submissions to everybody that attends. And note that we will be recording these sessions and posting them on our YouTube channel, just to let you know. And if you have any issues and you would like to chat, or you would like to chat further, our email is ermstakeholder@cnl.ca. We'll be watching the inbox throughout the webinar. I forgot to introduce myself. My name is Mike Giardini. I'm a communications officer with CNL's stakeholder relations team. And the presenters today are Manager of CRL Decommissioning Program Execution, Patrick Akins, and Project Manager, Patrick Mansfield. So we will kick it off right away. And we will I'm trying to delay because our one computer froze. So I will have to pull up the presentation. Just give me a second here. This one, right? Okay. Live, eh? That's what happens. One sec, guys. I'll just it's loading. Now I will have to share my screen. Okay. And it's okay. So Patrick Akins, why don't you start off by introducing yourself, and we will get the presentation up in a sec.
Great. Thank you very much, Mike. Good morning, everyone. My name is Patrick Akins. I'm the Program Execution Manager with Facilities Decommissioning and Environmental Remediation. I'm coming up on 9 years of experience working on complex decommissioning projects here at CNL. So again, the focus today will be on Building 250 decommissioning, but I'll start off by giving you a little information about the cleanup function and how facilities decommissioning fits into that big picture. I'll also give you an update on decommissioning at Chalk River Labs, including some of our waste statistics. Then I'll speak to the evolution of our team, where we started and the progression towards our major projects and our high hazard reduction. And finally, I'll hand it over to our project manager for Building 250 to speak to some of the incredible progress in this facility. So Mike, if you have it up, we'll go to the cleanup function slide. Great, thanks. So in a nutshell, the cleanup function provides a consistent process to enable all CNL sites to establish the right next land uses. The function is comprised of 3 programs: the land use program, decommissioning demolition team, and the environmental remediation process. The decommissioning and demolition program ensures that CNL is decommissioning and demolishing facilities in a consistent and defendable manner that aligns with our site goals in order to reach the next land use safely and effectively. For more information on the cleanup function, please check out our CNL YouTube page, as this topic was discussed in more detail just recently. Next slide, please. So prior moving over to the GOCO model in 2015, the facilities decommissioning program was very small and focused mainly on storage or surveillance activities. Once the GOCO model was implemented, CNL was mandated to accelerate decommissioning at Chalk River to safely control our liabilities and to generate space for our new builds. So in those early years, we started very slow. Focus was on hiring and training staff here at Chalk River and building in-house skills and capabilities using our local workforce. The majority of the work that we did was hazard abatement, characterization, simple small-scale demolitions to build up our skills and experience. A few years into the accelerated plan, as we gained more experience, we moved to more complex buildings and structures, smaller scale active demolitions, and multi-story buildings. And more recently, we've increased our headcount to over 300% since the GOCO model was put into place. And really that's in preparation for numerous high hazard facilities that will be turned over to us. We've really increased our investment into tools and technology so we can decommission these complex legacy facilities in a safe manner. Next slide, please. So really speaking to our waste statistics since the GOCO model was implemented in 2015, we've demolished 114 buildings, which represent a footprint reduction of 280,000 square feet of liability reduction. What I really want to focus in on and what we're really proud of is this clean waste statistic. Over 20 million kilograms of clean waste removed from the site. And that's really centered around our robust characterization and sampling program. That enables us to understand all the waste and hazards in our facilities to deem them if they're clean or active. So clean waste usually comprises of construction debris, wood, concrete, recyclables, metals. This stuff is all taken off-site to be processed. Asbestos, we have large quantities of asbestos. It was readily used in our buildings from the 40s and 60s for insulation. It's all handled and removed by asbestos qualified individuals on our site and on our teams and shipped off site. Our hazardous material, our lead and PCBs, about 47,000 kilograms of that has been removed. That all goes off site as well too. Our low-level waste, we've generated about 3.1 million kilograms of low-level waste. These are all items that are destined for NSDF. That usually contains a lot of the PPE that we wear, and it mostly comprises of the contaminated systems, service, and components, such as piping, tanks, contaminated concrete. That all is destined for an NSDF. We then have our mixed category, which is a mixture of hazardous and low level. That's all processed off-site as well too. And finally, our intermediate and high level waste, very little of it is generated within facilities decommissioning so far. This waste is not destined for an SDF. This goes to our shielded facilities and towel holes here on our site. And with our high level, there's very little, about 800 kilograms of high level waste generated through decommissioning. This has mostly happened through our rod bay cleanup and our hot cell cleanup. Next slide, please. So really, we're moving into our major project portion of the decommissioning stages here at Chalk River. So with the turnover of many legacy facilities, there's a need to restructure our teams to focus on the high hazard reduction in these major projects. These projects are generally higher risk, longer duration, and have a greater variability of work. So we focused on 250, which we'll speak to very shortly, but we also have our 200 series, which was our rod bay facilities for the NRX reactors. Also did thorium and plutonium reprocessing. In addition, we've also added and had a focus on reactor decommissioning, resulting in the formation of 2 new teams to oversee the NRX and NRE reactors. And I'm sure we'll have more information to come on these major projects in future webinars. Next slide, please. So really the major goals and outcomes for our major projects division here in facilities decommissioning. This is really the first real major nuclear decommissioning project in Canada. So what we're doing is developing our decommissioning processes and procedures that align with our regulatory commitments with the CNSC. We're standardizing our approach to complex work through mock-ups, training, execution, and lessons learned. And what we are is we are leaders in decommissioning here in Canada at CNL. We specialize in our characterization, our remediation, our active system and component removals, as well as our radiological protection practices. The ultimate goal from this major projects division is to be commercially viable, build up our in-house capabilities here at CNL, and be able to assist other decommissioning challenges throughout our country of Canada. So that's that in a nutshell. With that being said, I'd like to hand it over to Patrick Mansfield, who's the project manager for Building 250, to speak to all the exciting work that's happening in this facility. Thank you.
Thanks, Patrick. I guess in addition to sharing names today, we're sharing wardrobes. That was unplanned. Okay, welcome again. My name is Patrick Mansfield. I am the project manager responsible for the safe decommissioning of Building 250. Today we're going to cover the history. We're going to talk about the sort of decommissioning process that we apply as a whole, not only to Building 250, but to other facilities here at Chalk River. And then I'm going to get into some of the major activities surrounding some of our high hazard work we've done to get our source term reduction down in Building 250 and get it in a position ready for demolition. So Building 250 has a pretty impressive history. It's a large, multifaceted facility. It was built between 1949 and 1953. It was built in various phases. So essentially stemming from the North Tower, which is shown here on the right side, facing the front of the building, to the Central Tower in the middle, and then the South Tower to the left. Based on its uses and its construction, it's built with concrete, mostly in the North Tower. In the Central Tower, it's mainly concrete and wood because it's just an office facility. And then the South Tower, again, a good general mix of concrete, steel and wood. A big steel structure was put in the South Tower to support a high lift bay on the first and second floor. Next slide, please. So this picture here on the left is taken in 1949. It's the Wilkes Tower, is the very first tower to be built as part of the North Tower facility. Funny enough, the North Tower was actually built in around 3 to 4 different pours or phases. So here on the right, you can see that they're doing the shoring material for the forming for the next concrete phase. So in the background, you can see that tiny structure here. That's a photo on the left. Next slide. The photo on the left shows the North Tower almost in its complete state as it stands today. This picture was taken in the spring of 1951, and we're looking northwest. Again, on the right side, again, this is looking southwest. As you can see, the tower itself is almost finally complete. The last pour is happening here on the right side before it's finished. Next slide, please. So with that respected history, a lot of work happened with solutions of appreciable radioisotopic activity. The South Tower most recently held our tritium facility and various skids and equipment in support of our hydrogen program. Prior to this, it housed various fume hoods, test loops, and skids for experiments in support of the heavy water program and in support of our on and off-site reactor operations. The North Tower most recently housed the hot cell facility, which is used for multi-purposes stemming from dissolution of irradiated fuels and testing of low activity specimens from pressure tubes. In addition, the North Tower housed fume hoods, high pressure and high temperature test loops, and equipment supporting corrosion and decontamination activities for on-site reactor operations and equipment, as well as off-site reactor operations and equipment. Next slide, please. With the 70 years of operation, you can appreciate that we have left a number of hazards in the building. So we have radiological hazards, we have industrial hazards such as lead, asbestos, and chemicals. And then based on obviously the construction of the facility, we have a pretty significant fire load based on all the wood construction. Next slide, please. So just to give you a general idea of our timeline, we received Building 250 in 2018 after our chemistry division was moved to more modern facilities. We then went into a significant cleanout activity. Now we're at that source reduction and general decommissioning phase. Then we're going to work towards getting into our demolition and work towards our end state of leaving the facility as a brown space here on site. The decommissioning process, if you're not familiar with it, basically follows a process in which we adopt not only to 250, but to our other facilities here at Chalk River, which is also sort of an industry practice. It entails essentially getting into the building and doing immediate scoping or assessment. So we want to understand the history of the building, what operations took place in the past, so we can best sort of develop a plan on how we're going to approach safely demolishing the building. After scoping, the identification of hazards is our main focus and probably the most priority for us to work towards abating, as we don't want to expose any of our workers or the environment to any undue hazards as a result of our decommission activities. In parallel with hazard abatement, we get into characterization. Excuse me, that is a continuous process from the onset of getting the building to the very end prior to demolition. Characterization is the process of essentially pulling back the layers of an onion to get down to the very core of the original building structure. We do this by providing samples to off-site or on-site analysis, which then drives how we remove SSC or systems, structures, and components removed from the building before we get into preparation for demolition. In parallel with this, we do have a heavy waste management program that we follow, as well as we are maintaining our regulatory compliance to our decommissioning license here for Building 250. Next slide, please. So just covering off again that general process. So I'll talk about scoping, characterization, sample analysis. Excuse me, the entire building is characterized to determine the appropriate waste path. So samples are taken from the general surface, active and non-active piping, components and equipment, and even the structure for analysis. These samples are analyzed both on and off site depending on availability, and this provides the characterization team with the appropriate types of radioisotopes or industrial hazards present, so we can define the appropriate waste path for that waste. All results are documented, and it feeds into our planning team's approach for safely removing some of the equipment. Next slide, please. As I mentioned, hazard abatement is the top of our list. Again, hazards cannot be just industrial hazards, but they can also be radiological hazards. Here on the slide, we're showing some of the prep work that goes into doing asbestos abatement. Asbestos, as Patrick mentioned, is predominantly used back in the construction in the 40s, 50s, and 60s. We have it in floor tiles, ceiling tiles, asbestos wallboard, compounds, and pipe lagging for our steam systems. The planning that goes into these packages are quite significant. The work is governed by our industrial hygiene team. And of course, once we complete the removals, all the waste is bagged and disposed of, and air clearances are completed to allow staff back into the areas prior to the abatement or post the abatement being completed. Next slide, please. In addition, if you've been around the area or if you've been to our site, the use of asbestos siding was a very popular choice in construction back in the 50s and 60s. It basically is on all our legacy buildings built at that time. So that is another area where we focus our abatement activities. So to do this, we first have our radiological team go and scan the exteriors of our buildings. This is to ensure there's no contamination present on the tiles before we plan the removals. Once checked, our field staff then get on our articulating booms here shown on the left, and they start removing these pieces of siding piece by piece. Once all the asbestos has been removed and bagged and sent to its appropriate waste site, we then cover the building to protect against weather and insects so we can have it ready for demolition. Next slide, please. So lastly is our removal of systems, structures, and components. As I mentioned, we go through a significant characterization campaign on these pieces of equipment in order to determine how they will be removed, packaged, and sent out of the building for appropriate waste management. Here, our team is doing a removal of fume hoods. These are active fume hoods. You can see if in the picture, you can see a core or a core hole saw taken in that fume hood that was sent for, again, a coupon. So it directs on how we would bag and package this waste. SSCs for us consist of fume hoods, skids, test loops, active drains, active exhaust ventilation, etc. Next slide, please. So to Pat's slide on statistics, these are our specific statistics for waste to date at a building 250. We've taken over 150,000 kilograms of waste out of the building. Happily to say that around 50% of that is clean waste. One thing that we don't present here in the slide is the amount of waste that we remove and actually reuse. So I will be talking a bit more about some of the items that we reuse, but we do try to ensure that any quality equipment that can be repurposed is done so instead of going to waste. Next slide, please. Okay, now we're going to get into some key project activities that have happened within the building. We'll start with the trading facility. So in 2019, our team sort of kicked off scoping of this work. The trading facility housed 2 glove boxes that were used to work with tritium in various chemical forms. The most common are tritium gas, usually stored as metal tritide. To capture that hazard, the team brought in some SMEs who were familiar of operating these glove boxes. We returned the glove box to service, where we were able to capture the remaining heel of the tritium within these boxes, and it was removed safely and sent to our existing tritium facility where it's going to be stored and possibly repurposed. Once the tritium hazards were removed, the team began the process for isolating the system within the box, retrieving the samples for characterization to help determine the next path forward. Next slide, please. Once all the tritium and the components were removed, the team was able to demolish the boxes and downsize them to their appropriate sizing for their waste path. In addition to removing the tritium out of the glove boxes, there were various tritium sources still within the fume hoods. All of those sources have been removed and remediated accordingly. Now, as you can see in the picture to the left, we have an empty lab, and on the right is there a picture of our dedicated team who over a 2-year period were able to remove up to 90% of the building's tritium hazard with 0 safety events. Next slide, please. Within the North Tower houses our hot cell facility. We have 2 hot cells 3 and 4, and upon receipt of them from turnover, they were actually left in a pretty dire condition with a lot of the waste safely housed within the hot cell itself. So the team began with scoping and assessing the waste. What did we have and how were we going to remove it? That went into development of a waste management plan and a method to retrieve the waste. To do so, the workers spent time with hot cell SMEs, subject matter experts, to provide them the knowledge they need to understand historical operations, what the waste is, and how best to handle it. The team went into mock-up mode, where they went to another hot cell facility to learn and utilize the manipulators. That's shown here in the middle slide. Manipulators are essentially extensions of your hands that allows the team to work within the cells without having to expose themselves to radiation. And they can do so by looking through this shielded window. These are 8-inch thick shielded windows filled with lead. Next slide, please. So to support the waste removal campaign, we reutilized some of the existing flasks from the previous operations of Building 250. We developed plans, we set up a mock-up to practice and then put into execution. The team safely extracted all of the specimens used for previous sampling and have shipped them off to an appropriate site. Once the major source terms were removed from the cells, we were able to send bodies safely in to remove the remaining equipment, as seen here in the middle photo. And now with the cells emptied and complete, our team went into a significant decontamination exercise here, showing the application of a decontamination gel, which essentially captures loose contamination, which can easily be peeled and disposed of. A really great product. Next slide, please. So once we focused on removing the source terms out of the inside of the cells, we can then focus on getting the cells ready for demolition. The first task that we did this year was to remove the manipulators. We have a pretty dedicated crew of experienced trades and techs who supported our RP staff with removing these manipulators, which are then sent off for decontamination and repurposed in our existing hot cell facilities. So again, another item here where we're reusing equipment coming out of the building. The middle picture shows the campaign we did after removing the manipulators to remove the hot cell windows. So each hot cell window, or each hot cell themselves, contains 2 windows. Each window weighed around 800 pounds. These windows were safely extracted, packaged, and are now being saved for reuse in our new hot cell facility plan for, I think, construction by 2030. Looking forward, our hot cell team is now underway with the characterization activities to understand what remains in the concrete structure and determine if any remediation is required prior to demolition. Next slide, please. The last significant source term within the building was an active storage tank housed in the basement of our facility. As with all major projects, our first focus was to understand the contents within the tank because there was little to no data available. Sampling was completed by our field team in 2020. Workers donned extra PPE in anticipation that the solution in the tank might be of liquid form. So that middle picture shows our staff who are in full rad suits with an additional chemical suit on top with full-on face respirators. Upon doing the sampling, we did find that there was liquids in the tank, and that's shown here with a picture image on the right side. The sample was successfully retrieved, and it was sent off to our internal analytical chemistry branch for characterization. Next slide, please. So upon receipt of the characterization data from the analytical chemistry branch, we determined that we will require the need to transfer that liquid out safely, and based on its the expected dose rates, required a shielded flask to move this safely out of the building. So the team got together, we worked with a design firm, internal and external, and we're able to develop on the left here this active storage tank liquid transfer flask. Once that flask was put into motion, we then switched our efforts into developing a transfer system to pull the liquid from the tank into the active storage tank. The team developed basically a glove box pumping system, which then draws liquid. Rachel, if you can, just click on and we'll show the process for drawing the liquid of the tank. If you can click on the slide. So it draws the liquid from the tank. Click again, please. The pump pulls it through into the glove bag and then pushes it down to the active storage tank. This complete system was built with redundancy, so the flask itself has a primary and a secondary containment to ensure that we don't have any loss of liquid, as well as even the couplers that draw the liquid into the tank have leak protection built into them. The transfer system itself was also had double containment, so we protected against any failure scenarios while transferring the liquid. Next slide, please. So once these design and equipment was being built, the team spent around 6 months in a full-scale mock-up where they practiced day in, day out the process to draw the liquid from the tank into the flask. This time was considered invaluable and continues to be adopted for many of our high hazard activities at CNL. Come execution time, the field team was comfortable to work, the hazards, and the individual roles. During execution, staff are monitoring the transfer in close proximity to the tank, which you can see here in this middle picture. That's within the room, and you can see the glove bag with the piping. A second team was located here next to the flask, which is the farthest picture on the right. And what's not seen while all this was going on was a separate team who was essentially quarterbacking this work from a central point in close proximity via remote cameras and remote communications. So safe extraction of liquid was completed exactly according to plan with 0 safety events. Before we jump to the next slide, I think it's pertinent to state that we took the contents of this flask and we have taken it to a hot cell facility on site where we put it through a cementation process. So we've moved the liquid into a solid state versus a liquid state, which is much more manageable from a waste management perspective. Next slide, please. So upon safe extraction of the liquid, the team went back to the mock-up to work out the planning details to safely remove the lead around the tank. So here's the picture of the actual tank in the basement on the left side. It had a 2-layer of lead shielded around it. So the team developed a process to safely handle each one of those pieces of lead, which weighed roughly 50 pounds. The team then moved into planning and practicing the safe extraction of the tank. We put it into the field this fall. The lead removal was successful. The tank was removed from the basement and put into a storage vault, which is this black vault here being loaded into the waste bin in the middle picture. And by the end of November, the team had completed the extraction and the job was completed. And again, a happy group here showing off their smiles on the pitch on the right after successful shipment of the bin out of the building. Next slide, please. So with the majority of the high hazards now removed from the building and the team's focus can now switch gears to the demolition, we underwent optioneering on the best method for structural demolition of the building. Due to the structural designs of the towers, and as a result, they were built in phases, we determined that a staged demolition is the recommended approach. We will be moving into detailed design this year. Detailed planning is underway with our site SMEs. As a result, this demolition isn't remote per se, because we do maintain operations around this building. So we have a lot of invested stakeholders who will help guide us into the safe demolition of this building. Next slide, please. So this is just a rendition that we used as a conceptual way to show some stakeholders how we intend to remove the building. So again, focus on removing the central tower first to open up some real estate for heavy equipment and the waste management. Then we want to move the top alcoves off the buildings as a separate demolition to ensure we minimize any interactions with our neighboring facilities. And then focus on removal of the south tower. And then lastly, to the north tower, which again, being 100% concrete, is going to be a much slower demolition, as we're going to have to really do a lot of segmentation of the structure itself to safely demolish it with the surrounding facilities and operations at Chalk River. All waste will be appropriately cleaned up and shipped to our NSDF site, which is expected to take all of this low-level waste that's deemed suited for that waste disposal site. Well, thank you for participating in the webinar, and thank you to our project team members for their efforts to support this key cleanup function in our decommissioning portfolio here at Chalk River Labs. pass it back to you, Mike.
Okay, perfect. Thank you, Patrick Mansfield and Patrick Akins for that presentation. Lots of information on a pretty important decommissioning project on site. So we will go to questions. The first will be, why are buildings turned over to decommissioning in poor condition and in lots of operation wastes? What is CNL doing to better this practice?
I'll take that one, Pat. Give you a break for a minute. This is a really good question. Why are the buildings turned over in the state that you're seeing? So I think originally too, when we talked about that accelerating plan for decommissioning, there was a quite a rush to move people out of aged facilities to get them into newer structures. So for building 250, for example, we do have a new building 215 that handles our tritium experiments. Essentially, we were running experiments in building 250 right up until transfer date to decommissioning. So essentially, the way that was handled in the past, again, with a lot of volume of turnover, was that because of the operations and facilities, the people that were most suitable to handle the waste at the time was our decommissioning teams. What we're doing to improve on that, there is a phase of decommissioning now that we are really putting a lot more emphasis on, which is called the POCO phase, or the post-operational cleanout phase. This is where we integrate members of our team with the operations team up to years in advance prior to transfer to decommissioning. This is where we're helping individuals in operations in these facilities to get early characterization data on legacy waste and identify pathways for it. Again, a lot of the focus of this post-operational cleanout phase is to remove a lot of the loose waste in these facilities and do so in an appropriate manner. So I do feel there was a lot of buildings that were turned over in the early stages. Now that we are in about 50 different facilities in decommissioning right now, the amount of buildings being turned over to us, it has slowed down until the remaining new builds are up and operational. And I think we're working really closely with the operational teams to make sure that that transfer of knowledge is there and that they're being transferred in a more safe state. But good question, thank you.
Okay, perfect. Thank you, Patrick A. So there are a couple that have come in on the active storage tank. Now, we don't want to put you on the spot, Patrick's, for specific numbers. Just know that if you don't know something off the top of your head, we can write the answers to all the participants after we're done this. On that, what was the residual radiation field following the removal of the liquid from the tank? What was the volume of the liquid pumped out of the tank? And did you consider solidifying the liquid in the tank followed by the removal of the tank?
I'll try to tackle this one, Mike. So maybe first off, which I didn't mention, is this tank was used in a process back in the 50s where they were taking active liquid and experimenting with ways to solidify it into a solid waste by making it into glass. Again, managing solid waste is a lot easier than liquid waste. When we completed the characterization, there was around 15 liters of this solution that's left in the tank. It did contain minor traces of americium and plutonium, but at very, very small scales, and it was more of a nitric acid solution. We did look at cementing it within the tank. However, we wanted to safely extract it first, as we didn't know the condition of the tank if we were to consider, for instance, cementing it in place and then compromising the structure of the tank and therefore having an unplanned release in the building. So safe liquid extraction was the route that we chose.
Okay, thank you. What was the main source term in the active storage tank?
So again, it's I don't know the actual readings. I'm not going to try to guess what the readings are or the dose rates were, but again, it was a nitric acid solution that had alpha particles such as americium and plutonium within the solution, but I can't speak to what the actual overall amount of source term coming off the solution was.
Okay, thanks, Patrick. Yeah, and if more information to the person who wrote the question, more information, you can always contact us and we can get you more information. But we'll go on to the next one. How do you plan decommissioning in a building that's so old in different stages throughout the decades when records aren't always found? How do you plan the decommissioning around that in different stages?
I can take that, Pat, or you?
You go ahead, Patrick, and I'll
Sure.
back you up if I need to.
So again, a building like 250 is quite different. I think we have a wide variety of buildings on our site that we've decommissioned, again, from small little sheds up to multi storage facilities with multiple labs, such as building 250. So the approach to our knowledge doesn't change. So from facility to facility, we still, before the building's handed over to us, I talked about that operations to decommissioning phase. That's where a lot of the gap analysis, or where we find out information from historical site assessments. We generate documents such as building removal plans or detailed decommissioning plans that have a lot of that general information and knowledge about it. And I think to Pat's point a bit earlier, it's like peeling the layers of an onion back. So again, the big phase for us in decommissioning is that characterization phase, where without knowing the history of the facility or taking those samples and analysis, where we figure out what happened in the facility, we are not able to proceed with that type of removal. So it doesn't matter if it's the smallest little shed out in the woods to compare to this. It's the same approach where we go through those historical site assessments, do our characterization data, and really build the picture on how we're going to decommission that process.
Okay, thank you. To build off that, the next question is, were there any surprises, unexpected findings during the decommissioning? If yes, how did the team tackle it?
I'm going to say that we didn't have any, significant surprises in regards to, either, hazards that we were pre-identified or the source terms that we knew were within the building. And the only real surprise I'd say that we come across most commonly is with our configuration management and either what's on the drawings that we have available to us, what's found in the field. So nothing in regards to more the source and the hazards that presented with each source, but more that we're finding the drawings that help us into our planning aren't always exactly as we find them in the field. So we do always plan for that, because we always know that's a risk in our execution, and we always talk and plan for mitigation activities that support the unknowns when we're doing work specifically with our high hazard activities.
Okay, thank you. Next question, can any of the decommissioning information be used to improve future designs, for example, future tritium glove boxes?
Great question. Again, I'm going to say that we don't do a lot of sort of feeding back into our S&T program for new designs of new construction facilities. There is a whole dedicated team in regards to, improving our site S&T facilities and the equipment that go into them. So I'm going to say that we don't feed a lot into that from a decommissioning perspective.
Okay, thank you. The next one is a little out of scope, but we did just have the waste acceptance criteria discussion kind of at the first webinar, and integrated waste strategy. And it's a question about NSDF. So we can go back to that team and maybe answer this full in a written email to everybody. But I think maybe the first part of the question can be answered. Could you please describe more about the end state of decommissioning of 250?
I can take that one for more of a holistic approach to any of our end states and how they're developed within decommissioning. But essentially, the end state is developed prior to decommissioning. Again, this is a regulatory commitment that we have. So for Building 250 as a licensed facility, this requires a detailed decommissioning plan, which strictly tells the regulator, the CNSC, our approach to decommissioning and what the end state of that will be. That needs to be approved by the CNSC in order for us to proceed into decommissioning. But to get us to that process, I spoke to a little bit how we focus into the land use and where we sit in decommissioning. But again, it's an integrated approach to identifying what the next land state or use will be. Again, for Building 250, it's in prime real estate in our controlled area. Potential uses are for new builds in the future. But again, the intent of our end state is to demolish the upper structures and to get down to slab on grade. And again, anything that's below the surface is really destined for the third phase of that program, which I spoke to, which is environmental remediation, where we go in and we tackle all below ground structures at one time and remediate the lands that are affected. So it's the same approach. Again, we have licensed facilities and non-licensed facilities, but generally speaking, the stakeholder engagement and the involvement is the same.
Okay, thank you, Patrick A. Yeah, so for the rest of the question about if the waste will meet the NSDF waste acceptance criteria, we will go to those subject matter experts and get an answer for you, and we will write that in an email out to everybody that is watching this webinar this morning. So the next question is, how would you plan to tackle residual alpha contamination, specifically in the north end?
So without having all the characterization data yet, but assuming we do have some residual alpha contamination that remains, we will be focusing on, again, the characterization aspect. So once we get samples for locations, let's say any areas where it's impermeated into the concrete, we would take a core sample, send that off, determine how far it's gone within the concrete. Then we would utilize some of our existing practices that we've done on other projects here on site, where we would do scabbling, for instance, where we shave off a layer. We have many equipment that we've used to extract, that first 1/8 of an inch in the concrete and safely capture it and remove it. Or we get into a position where we would actually structurally dissect it out of the building if it was able to be done so. And worst case scenario, if we can't, we fix it and we deal with it as part of demolition. Perfect.
Okay. Thank you, Patrick Mansfield, Patrick Akins, for doing this webinar. That's it for questions. But like I said, we will have we will send out an email to everybody that was registered for this webinar with a link to the webinar on YouTube and answers for any questions we couldn't answer fully. And if you would like a copy of the presentation, please email us at ermstakeholder@cnl.ca. Once again, thank you for attending this webinar. Thank you, Patrick, once again. And we will maybe see you in a few minutes for the NPD webinar. So thank you. Take care.